So, any question about the exam before we continue? This is not a competition. أي سؤال. يعني شوف انت الان انا اعطيتك زي مثل التيبل حق البوكس مش عارف ايه. اوكي. In the table you can find if I select box 7 صح؟ هذا التيبل ما يبغى عليه. ما يبغى اي بروبلم. لكن اذا سالتك سؤال عكس given انه انا طلع لي الايتم هذا what is the item اللي انا البوكس اللي سلكته بوكس هنا لازم تسوي كذا لان ما هذا الوجه ما هي واضحه واضح يعني basically when I ask for a probability position probability that you don't have لازم تعكس لازم تقول والله probability A given B equals probability B given A اللي هي عرفها multiply by probability of B divide by probability of A اللي هي انا ما اعرفها هذه يجي بالكلمه واضحه شباب؟
السؤال البسيط مثلا probability of choosing box and probability of choosing factor mutually exclusive ولا exclusive؟
يعني تقول event of choosing a box event ثاني choosing a capacitor certain capacitor هل هو mutually exclusive؟ لأن هذا يدل على هذا في تداخل.
not mutually exclusive or not?
Not mutually exclusive means if I select one I cannot select the other. يعني مثلا box A و B هذول mutually exclusive. If I select box A مستحيل I select box B at the same time. إذا طلع لي نفس الشيء كلاسترز الآيتم item 1 و item 2. If I select item 1 I cannot select item 2. هذول الاثنين mutually exclusive هذول الاثنين mutually exclusive. لكن box A is not mutually exclusive. بينما box A and B basically this is they are not mutual. يعني واضح؟ سؤال ثاني شنو؟ جاهزين؟ سهل طبعا لا ننتهي بس يعني ما في فكرة كثيرة بس هي الفكرة في فوكس وحاول تلاحظ تأكد إنك فاهم السؤال ركز والأسئلة بعض الأسئلة صعبة ركز فحاولنا ننوع قدر المستطاع اللي مو فاهم هذه فاهم ذلك يعني ما تكون أسئلة أو تعتمد على بعض الخطأ في الأول يعني كل سؤال ما له if you miss one لأن مرات نفسيا إذا أعطيناهم ثلاث أسئلة في بعض A وسؤال ثاني ممكن بعض B وC D كله يخطأ يعني مرات ما له خطأ بس نفسيا خلاص أنت يخطأ فحفظ إن شاء الله والبي يعني التفاصيل ما لها بس ما تفرق معك هي الثالثة طيب نرجع مرة ثانية صور الصورة هاي بس اوريدي على تيمز افتح تيمز تلاقي الكلام هذا It's 6:125 ما يبغى يفتح تيمز اليوم صور الشاشة الله اللي جاء متأخر اختبار اليوم 6:25 الإكزام اليوم الساعة 7 بإذن الله طبعا تعالوا قبلها مدة عشان نفتح القاعة إن شاء الله ما تكون جلسة المدة نشوف طيب any other questions طيب آخر مرة last time we started to talk about the characteristic function. This is a characteristic function doesn't really have a physical meaning. Okay. However, it's a very useful mathematical function that is related to the PDF. The characteristic function is a useful PDF. What was the characteristic function? The Fourier transform of the PDF, right? So if I take the PDF, I take the Fourier transform of the PDF, I get what we call the characteristic function. And if you look at this Fourier transform is basically the same as expected value of e to j omega. هنا بنعملها physical بنعملها معنى حسي لكن it has a very useful function. It's a very useful function. We will use it later when we talk about when we add more than one random variable. However, for the time being, it's very useful in generating the moments. Then we will be generating the moments. The expected value of finding the expected value of x to the power n is usually the integral of x to the power n multiplied by t. So the integration is not a fun thing to do. It's not an easy thing to do. And because of that, one of the ways to get away from the integral is to use the characteristic function, differentiating the characteristic function with respect to omega n times, and setting omega to 0 will give you the expected value of x. And we know that differentiation is much easier than integration, right? So this is one very nice use. And then we will talk about the moment generating function, very similar to the characteristic function, except that this is the Laplace transform other than the Fourier transform. So there's no J. That's the difference. And similarly, because it's generated, because basically differentiating this n times and setting v to 0 will give you directly the nth moment. And because of that, they call it moment generating function. Function هذا أصلا شغله to generate. And we took example here, and today, inshallah, we'll take another example, and then we'll start the functions of random variables. When you have a function of random variables, what will be the PDS? But before we go there, let's talk about the moment generating function for the exponential distribution. So we did the characteristic function. Let's do the moment generating function. By definition, the moment generating function is the integral, right? It's basically integral of PDF multiplied by e to b x d dh v will x dx, right? So minus f. So basically, the PDF comes here, and here is e to bx. So now, in order to integrate this, you just combine the exponentials together, and whatever constant you get. You can see that there is a constant here, which is e to a over b minus a over b. We get it outside the integral, and whatever function of x remains here. And so basically, we have x multiplied by there's a v here, and the minus 1 over b. So basically, we get next to the x v minus 1. So integrating an exponential gives you what? Right? But you need to divide by whatever next to the x, which is x. And of course, setting it from 8 minus to infinity, you will get this result. Now, in order, for example, to find m1, which is the expected value of x, you need to differentiate the PDF, so the moment generating function, one time, and set v to 0. Differentiating it one time, basically you know how to differentiate this. The derivative of the first numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator divided by the denominator what? Right? So basically, if we do this, you will get some whatever. Now setting v to 0, you will get this will be 1, the exponential, and this will be 0, the v, and the v here will be 0, and you end up with basically when you set it to 0, you will end up with a plus b divided by 1, which is this. And we have found it before, you will do integration by part, the same answer. And we have done it also using the using the characteristic. Any question? Any question? Similarly, the characteristic function for the uniform distribution, if you want to find the characteristic function for the uniform distribution, basically it's expected value of e to j omega x. So basically it's e to j omega x multiplied by the PDF. This is the PDF of a uniform distribution between a and b. Right? And it's the integration between a and b. So it's only non-zero between a and b. Now, again, it's an integration of an exponential, which basically gives you the same exponential divided by whatever next to the x. So we get this. Any questions? Later, when we talk about if I have x plus y, how to find the PDF of x plus y. We find that later, this is not an easy thing. It's the convolution of the PDF x with y, which is very good. Now we will use the characteristic function to turn the convolution into product multiplication, because it's a Fourier transform. However, we'll come to it later. So this is, again, it's a very useful function, mathematically useful. Any question? Right, this is a self-study, just read about it, we'll not discuss it. Now, let's talk about a very important subject, which is the transformation of random values. Transformation, as I mentioned before, very important because in many cases, you are dealing with an observation, not a voltage, and you are interested in finding the power, how it current. You are dealing with the temperature in Celsius, you are interested in converting into Fahrenheit. You are dealing with anything, and you are interested in finding another function of that. So in order to be able to carry out such problems, you need to be able to figure out if I have a random variable and I input it into a transformation. Transformation. Then I need to be able to find the output random variable. Find it out. If I know the PDF here, the CDF, I need to be able to find the PDF of y, the CDF. If I know the PDF and CDF of y, I know everything about that. There's nothing more to know about a random variable more than the PDF and CDF. So now, given certain random variable at the input of a transformation, هنتكلم عن ايش الشكل الترانسفورميشن هنا, and I get at the output another random variable. Now I know the PDF and CDF of the input. I need to find what is the PDF and CDF of. This is the goal of this section. We will talk about it in terms of three main cases. The two first are continuous random variable x and y. So x is continuous. The transformation is continuous function. However, the first case, the transformation is monotony, either increasing or decreasing. يتغير باتجاه واحد، يعني يزيد ما ينقص، يعني ينقص ما يزيد. اوكي، مثال على المونوتونيك increasing function y equals مثلا e to the power minus x. This is increasing or decreasing? Decrease, right? Right. So monotonically decreasing is y equal e to minus x. Excellent. Another example. Monotonically increasing after example. Where is it increasing? Nice, well. Monotonically decreasing. Y equal كم? Exponential. E to x. عكس الجميل. طيب. What else? A multiplied by x, where A is positive, صح ولا لا؟ A is positive, A multiplied by x is monotonically decreasing. بينما A negative becomes monotonically decreasing. So this is the first case we talk. أول شيء نتكلم عن increasing and decreasing, but then we combine them together in one equation. X itself, no? Okay. X is a random variable. نتكلم عن the transformation اللي يدخل هنا. تحويل من x لواحد. What type of function? Our case monotonically increasing or decreasing, and then we give you the equation. And then the second one is x is continuous, the transformation is continuous, but non-monotonic. Means the x squared. The negative part is it, the positive part. This is another one. Now, what we did is, when we had x, we were able to find expected value of a function of x, g of x. Like we did not find f in PDF or CDF. So زميلكم يسأل مو نحن جبنا expected value of g of x? Knowing x, we were able to find x. We have done this, but we did not find the PDF and CDF of T of X. Okay, this is what we are doing. Thank you. And the last one is when X is discrete and the function is complete. So let's proceed with these three as a thought. Cosine of X is what? H line. Which line? H line. Y equal X. Y equal cosine X. Is it monotonic or non-monotonic? Okay, right? يطلع easy. Okay. Cosine of X is another example. Excellent. Right. Any question? So basically, these are the three main categories that we will talk about. Let's proceed with the first. The first one is when we have monotonically increasing function. So basically, if this is y, which is equals t of x, and this is x, then it's basically monotonically increasing. Let me check here. Z is it. So every time we increase x, the image y increases. Okay. Now in this case, in order to find monotonically decreasing العكس, you see basically as x increases, y decreases. In order to find the PDF of y, we need to define y as t of x. So the problem set up here, given the PDF of x, let's find the PDF of y. هذه هي الجول section. When we're monotonically increasing, if x2 is larger than x1, then t of x2 is larger than t of x1. صح? That's the definition of monotonically increasing. When monotonically decreasing, when x2 is larger than x1, when I go right in the x-axis, then x2 is smaller than x1. Right? Okay? Now let's proceed with finding the first case. خلينا نتكلم أول شيء على monotonically increasing function. Monotonically increasing function. In order to be able to find the PDF of a function of a random variable, let's go back to the definition of the CDF. يوم ما نتكلم عن PDF, let's go back to the CDF. What is the CDF of y evaluated at certain number, y0? It's equal to the probability that y is less than this number, right? لأنه احنا قلنا البي دي اف قبل كده تعطيك distribution اللي تسوي density. لكن this is the probability. This is easier to do. CDF. Now, what is the event? What is the equivalent of the event of y when y is less than y0? Let's see. Let's go back to the transformation. هذا هو y equal t of x. وهذا x. Okay. Now, the event that y is less than y0 is this. Right? This is the event corresponding to y less than y0. Now, in the x-axis, in the domain x, what is the corresponding event? نشوف y0 يقابلها ايش؟ x0. Okay? So when y is less than y0, when y is less than y0, x is what? Is less than x0, right? صح يا شباب؟ This is the equivalent event of y in x. So the equivalent event is x is less than x0. So the CDF of y at y0 equals the CDF of x evaluated at x0. صح ولا لا؟ شو عبارة نسويها؟ y0 is a number on the y-axis, x0 is a number of the x-axis. فكذا معناها ايش معناها؟ ايش العلاقة بين y0 x? Y is not exactly. So basically, what is y0 in terms of x0? ايش علاقتهم ببعض؟ It's t of this, right? So أنا عندي الآن CDF at evaluated, CDF of y evaluated at y0 equals the CDF of x evaluated at x0. So now, what is the CDF of y? CDF of y is the integral from minus of y of PDF of y of minus infinity to y0. And this is equal to the CDF of x, which is the integral
of the PDF of x from minus infinity to where? To x0. What is x0? Hi, Shimon. What is x0? The y0 equals t of x0. So what is x0? The inverse, exactly, of y0. So the CDF of y at y0 equals the CDF of x at x0, which is the CDF of x at f of x at at what, Shibab? At t inverse, exactly. This is equal to f of x evaluated at t inverse of y. Thank you. Clear? Now, so now I know the CDF of x, y in terms of the CDF of x. Right, what about the PDF? The PDF is about the derivative of the CDF, right? So differentiating this or differentiating this gives you the PDF of y at y0, which is the same as differentiating this. Now, if I differentiate this issue, differentiating this with respect to y0, what do I do? Right. And I have the function differentiating it with respect to a variable. What is the point? Differentiating fx, what do I get? Differentiating this function CDF ايش يعطيني؟ البي So اول شيء يعطيني البي PDF multiplied by what? Differentiating of derivative of the function الداخل صح ولا لا؟ This is exactly what we get. Differentiating the CDF will give me the PDF of x evaluated at x0, right? Multiplied by the derivative of whatever inside. D inverse evaluated at y0. واضح شباب؟ Clear? How do we do this? So طبعا هذه at certain y0. طبعا at any y, what do I get? PDF of y at any y equals the PDF of x evaluated at t inverse of y, which is multiplied by the derivative of the inverse function. But what is t inverse? T inverse is dt inverse y dy is the same as dx dy. هو المقلوب حق derivative of the inverse of the function. واضح شباب؟ Any question? باختصار اللي سويناه, we started with the basic probability of an event in y. We transferred the event into the corresponding event in x. And then we were able to find the CDF in y as a function of the CDF in x, which is the image of the inverse of y. And then we differentiated, we ended up with this. Any question? Again, هذه ما نحفظ، آخر شيء لازم تكون فاهم. We only start from the definition. خلينا نكمل الآن عشان تشوفوا الصورة واضحة. Decreasing الآن monotonic decreasing إيش يصير؟ أنا عندي function. Again, I start with the CDF evaluated at y0, which is the probability that y is less than y0. What is the corresponding event to y less than y0? And y0 has the image of x0. What is the corresponding event? When y is less than y0, what is the corresponding event in x? X is larger than x0, right? Because it's monotonically decreasing. When y is less than y0, x becomes larger than x0. واضح شباب؟ So the event y less than y0 is equivalent to the event x is larger than x0, because it's monotonically decreasing. Now, what is the probability of x larger than? It's 1 minus the CDF of x evaluated at x0. Now, differentiating this will give me the PDF of y. It's equivalent to differentiating this, which is minus differentiating this 1 gives me 0, minus the CDF will give me minus the PDF, multiplied by dx dy. Right? So if I have monotonically decreasing, I get a negative. باختصار monotonically decreasing, y equals some negative number multiplied by x. Or something that is decreasing with x. Monotonically, basically, derivative is negative. بينما in monotonically decreasing, the derivative of the function is positive. Right? When you differentiate this, what do you get? A negative function, whatever that function is. بينما monotonically decreasing, if I differentiate this, what do I get? A positive function, whatever that function is. So now combining both, لو تلاحظوا في البوزيتيف طلع لي positive، في النيجاتيف طلع لي negatively slow, which is also positive. Right? Negative, the negative is positive. And hence, regardless of the sign, regardless of it is monotonically increasing or decreasing, if t is monotone, يا يطلع يا ينزل. In this case, fy of y will be equal to fx of x multiplied by dx dy. Okay? Or fx of x divided by dy dx. Absolute value طبعا لو تلاحظوا. Okay? طبعا evaluated at x equals d inverse. نفس الشيء evaluated at x equals d inverse of y. Sorry. d inverse. واضح يا شباب؟
ايش بريكس دي واي جبناها وحطيناها.
Okay. الآن dx dy is the derivative of t inverse, right? مش هي نفسها 1 over dy dx is the derivative of y with respect to x. t is the derivative of t with respect to x. صح ولا لا؟
دي واي
يعني أنا عندي t dy the derivative of t with respect to x will be dy dx صح؟ اللي هي derivative of the function t. It's dy dx صح ولا لا؟ لأن y with respect to x. الآن نفس الشيء if I go to the next side أطلع من جهة x من جهة y. Differentiating t inverse is as if I'm differentiating x with respect to y. مو هذا هو المقلوب حق هذا. مرة تشوف من ناحية y مرة تشوف من ناحية x. ها؟
هو انا فهمت الدرس حق الانكس دي اكس ولا دي واي. طيب ولا الدرس حق
Transformation is dy dx. ايش علاقتهم ببعض؟ دي بعض. اوكي؟ لأن واحدة تشوفها يقول لك من جهة x والثانية من جهة
is it the one which is slow?
السلوب. طبعا not the slope, this is the derivative. السلوب لما يكون عندك only single function at certain point. يعني at y0 this is the slope. لكن if you have a function this is the derivative.
عشان كده نقول لك slow value إنه even with the minus increasing dy x of dy تكون minus
Exactly. لأن أنت لما يكون عندك monotonically increasing الديريفيتيف هنا is a positive function. لما يكون monotonically decreasing الديريفيتيف is a negative function. طب لما يكون negative function عندي negative معناها ايش الانسر؟ اصلا ما ينفع يا شباب ما ينفع يطلع لك PDF negative. صح ولا لا؟ So regardless of the slope you have to have a positive function لأنها it's a PDF. PDF من شروطها انها positive function. And because of that we put the absolute value. واضح؟ So this is now evaluated at x equals t inverse. Well, how did we do it? Again, what we did is, الآن ممكن أعطيك أي شيء ثاني. You should be able to feel comfortable starting from scratch. Starting PDF of y, what is it in probability, and then finding the corresponding event. يعني خلينا نقول نسيت القانون. You can always do that. واضح؟ Let's have an example. نعمل الحل شوي. مشاكل. طيب. Now we have a random variable x with this PDF. ايش ال PDF هذا؟ تذكروها؟ What is the أعطوني كذا ايش ال Gaussian هذا ايش عنده؟ variance equal 10. Yeah? Sigma square, right? Sigma square, what is the mean? طبعا الى الان في الكويز الماضي الشباب بيلخبطوا بين المين والستاندرد ديفيشن. يعني كده الشباب جابوا اف اوف اكس ماينس ستاندرد ديفيشن ديفايد باي مين. هذا واحد ترى مو واحد. وبي كيرفل ها. Standard deviation gives you the spread around the mean. بينما المين gives you the location where this is located in the x-axis. هل هي 0 ولا 10 ولا 100 ولا
Start getting the sigma x or
Yeah, again, another mistake. People divide, some students divide by sigma x squared. No. The f function لما تسوي له normalization is divide by standard deviation, which is the square root of the variance. واضح؟ هذا أخطاء شائعة على be careful. طيب, so this is a Gaussian with mean ax and variance curve. Now, a new random variable y is defined as certain transformation that is given by ax plus b. So this is a linear transformation. Okay, a typical amplification. You add a BC and amplification. We are interested in finding the PDF of y. Okay. Now clearly this is ايش رايكم؟ regardless of what a is. إذا a positive يكون increasing, right? إذا a negative يكون decreasing. But regardless, this is a monotonically increasing or monotonic function باختصار. monotonic معناها يتجه باتجاه واحد، حركة اتجاه واحد، يا يزيد يا ينقص، لكن ما يكمل يلف يدور. طيب, so basically fy of y equals by الديريفيشن اللي سويناه قبل شوي. This is monotonic قلنا. It's basically equal to f of x evaluated at, احنا قلنا evaluated at what? At x equal t inverse of y, right? So basically, it's fx evaluated at t inverse of y. What is t inverse? If y equal ax of plus b, then what is x in terms of t? T inverse. Yes. What is it? Nice. Solve for. Basically, what you need to do is find the 0, right? Are you following or yeah? What is x in terms of y? You need to solve for x, right? It's as if you are finding the 0 of this equation. So what is this? Y minus b over a. So this is the 0 of this function, as if you are finding the 0. So fx of y minus b, whatever, t inverse. So this is basically equal to t inverse of y, evaluated at x equal to inverse. Divide by the derivative. What is this? Is هذه ايش كان شباب؟ d x dy or dy, sorry, 1 over, thank you. Or it's 1 over dy dx. Both of them evaluated at, again, x equals come t inverse of y. And luckily, dx dy is not a function of y. So basically, it's 1 over a. Absolute value because it's regardless of monotonic increasing or decreasing. واضح شباب ايش سويناه هنا؟ So it's PDF of x, y equals the PDF of x evaluated at the inverse of the function. Multiplied by the derivative of x with respect to y, or divided by the derivative of y with respect to x. Either way. Absolute value. Now we know the PDF of x. Just plug and play. Okay? Wherever you find y, wherever you find x, insert instead of it y minus b divided by a. So whatever x, you just replace it with y minus b divided by a. Okay? And you need to divide by 1 over a, so 1 over a comes. Under the square root, it becomes a squared. Now, just simplifying, opening up this, it's y minus ax. You need to basically take a here and insert it down, take it down. So basically, it will be y minus all this, ax plus b, divided by, next to the sigma square, you find a square. Well, try to simplify it. Try to go from here to here. So our سؤال Basically this is the PDF of y. ايش رايكم؟ ايش شكله؟ What is the type of y? What is y? Describe for me y. Is it exponential, uniform, شيء تعرفوه ولا لا؟ binomial? What is y? يا شباب. Gaussian, right? Why is it Gaussian? I Gaussian معناها ايش؟ معناها ما في شيء x هنا، ما في y هنا، and it's y minus a constant to the power square. صح؟ This is a Gaussian. It's an exponential with respect to minus y minus something square, يعني all square, and here there is no y. If there is a y, it becomes radial. So now it's Gaussian. What is the difference between this Gaussian and this Gaussian?
Yes, so linear transformation doesn't change the
No, it might change. Here it didn't. هنتكلم بعدين هنتكلم عن transformation of Gaussian random variables. When you have more than one Gaussian random variables, that linear transformation of Gaussian always gives you Gaussian. بس مو شرط الاشياء. يعني السؤال if this is the Gaussian and this is the Gaussian, what's the difference between them? ايش الفرق بين x و y؟ نعم؟ المين والفاريانس صح اصلا Gaussian عن Gaussian ايش الفرق بينهم؟ المين والفاريانس. So what is the mean of y here? What is the mean of y? من equation اللي قدامك. What is the mean of y? It's basically expected value of y واضح كم؟ ax plus b. Right? And what is the variance of y? A square x sigma x square, right? الآن بدون كل هذا, you know, without going through the transformation, if I tell you, if I ask you, what is the expected value of what? Of ax plus b. You should be able to find this. We know at the moment, right? What was this? Actually, yeah, it's basically, this is equal to the expected value of the first plus the expected value of the second. And what is the expected value of the first? We're going to constant يطلع برا لأنه it's constant. So it's a expected value of x plus what is the expected value of b? Constant, it's b. So what is this? What is the expected value of x? It's ax plus b. So بدون ما نسوي الكلام هذا we know how to find the mean. لكن احنا ما كنا نعرف قبل انه output y is Gaussian. Like at least from the moment's point of view, we know how to find this without finding it. And similarly, we know how to find the variance. The variance will be basically following the same will be x squared. So simply, if you linearly transform a Gaussian random variable, you end up with Gaussian, but the mean will be the same function, will follow the same function of that, just replacing x by ax, and the variance will be whatever the amplification factor a squared multiplied by the variance of x. هذه النتيجة الكلام. Linear transformation of Gaussian random variable reduces another Gaussian variables with the mean equals the same transformation with respect to the mean, and the variance equals a squared x. Any questions about?
Variance, value function square.
The variance will be expected value of x, يعني y defined minus the mean of y, also other variance, which is equal to the expected value of y squared minus the mean squared. Any question? Fine. This is the monotonically increasing or decreasing. Let's have an example, another example. Now, what do we have here? We have a Gaussian or a Gaussian, random variable x, so Gaussian, yeah, has a mean value of ax of 2. So the mean is 2, and the variance sigma x squared is 5. Now the voltage x is applied to a square law full wave diode. So what is y with respect to x? For the transfer function characteristic, y equals 7x squared. Square law, full wave diode. Find the mean value of the output voltage. Y. هذا أول شيء. ثاني سؤال. What is expected value of y? شباب. It's expected value of whatever inside, right? What is y? 7x squared, right? As you think just mentioned, 7 expected value of x squared, right? What is this? Do we know it? Second moment of x, do we know it? ايش هي؟ نعم؟ Yeah. You can go through the integration and so on, right? However, we need to do that. Can من المعلومات اللي عندنا, can we find this? Is it equal to the variance? Minus basically the variance plus the mean. It's the variance of x squared plus the mean of x squared, which is come قلنا ax. يعني خلينا نسميه x bar, right? X bar, right? What is the variance of r equal to? هذا مهم ترى. The relationship between the variance and mean square هذا مهم جدا. And we find it in many cases. And what is the variance? Right? الآن لو كان معطيك بدل variance قال لك standard deviation equal to. So what will be the variance? Square of that will be 3 square. Huh? لازم شوية بين ال variance and standard deviation. So it's 5 plus كم? What is the mean? It's 2 square, right? So what is this equal? 7 multiplied by 5 plus 4, 9, 7 by 9 is come 60. So this is the average of the mean, the output. Now, a random variable x undergoes the transformation y equal 3 minus 3 over x. Find the density function of y. So this is now a transformation. It's not only the moment. We want to find the PDF of y. أول شيء هذا monotonic decreasing or decreasing? Decreasing. مين يقول decreasing or increasing? Increasing? As x increases, ايش يصير 3 over x? Decreases, right? What happens with minus that? Increases, right? Okay. So now the PDF of y equals what? دائما ترجع للقانون. What is this equal? F of x, sorry, evaluated at f of x evaluated at what? T inverse, right? So T inverse of x of y, sorry, of y, right? Multiplied by the derivative of x with respect to y. Actually, right? Again, evaluated at x equals T inverse. Now, the first one, what is T inverse of y? Yeah, so y equal this means x like minus 3 over y, right? This is the first thing. Now, the derivative of this, d x dy, what is this equal to? 3 over y squared. Great. So now just plug and play. What is this? So fy of y equals what? It's fx, it's Gaussian, right? So basically it doesn't matter. It's fx evaluated at minus 3 over y. So whatever fx doesn't matter. Gaussian, exponential, uniform, doesn't matter. However, I evaluated at minus 3 over y multiplied by dx over dy. What is dx over dy? It's 3 over y squared, right? واضح? So it will be 3 over y squared multiplied by the PDF of x, regardless what that is. However, evaluating it at minus 3 over. واضح شباب؟ So next time, inshallah, we'll talk about a non-monotonic, when basically x, y keeps fluctuating or has different values, more than one value. تفضل. الاكس monotonic. Transformation K is monotonic means non-monotonic هنتكلم عن some يعني similar deviation that تكون generalization. Any question? Thank you very much. We'll see you inshallah. لا تنسوا الشباب الساعة 7 في building 625. So they did there in the teams. Okay. That's good. بس الفيرينس عبارة عن هذه ماينس هذه عبارة عن فيرينس بس يعني الفيرينس اللي بدينا اشتقنا قلنا انه هذه يكون هذه ماينس هذه.
اكس ماينس اكس الكل سكوير هذا هو
الفيرينس هذه معناها يكون كام؟ هذه بس هذا واحدة ناقص الثانية ودي ناقص ناقص.
Victor, if you have f of the standard deviation equal to a number, how do we cancel to get the standard deviation?
Okay.
F of the standard deviation, we don't know it, equal to a number. We know it. How do we find the standard?
بس